Hello, everyone, and welcome to AWS Heroes in Conversation. Today, we have Elliot Cordo with us. So he's right there over here, and he's going to talk about Glue and Redshift Spectrum, that is virtualizing data ingestion. But before we continue ahead with this session, I will request Elliot to introduce himself and let us know what he does.
Yeah, thank you. I've been an engineer, data engineer for more than 2 decades. I am a AWS data hero, and I currently work as head of data at Capsule.
Nice, welcome. Thanks, Elliot, for removing some time and chatting with us today. So let's continue further ahead. If we can just go to the next slide, and maybe I'll hand it over to you from here. And if you can give us a brief insight into this topic, that would be perfect. So thank you.
Yeah, so today we're going to talk about using specific AWS analytic services to solve a really worthy problem, which is moving data around. So, I think as a data professional, or if you ask a data professional, they're going to tell you that one of the number one wastes of time in the kind of practice of data engineering is making copies of data and moving data around. So, there's obviously some reasons that you want to do this, but we're going to go over some scenarios around building data pipelines where you can really save a lot of time by not ingesting data and just using like kind of virtualization.
Mhm.
So I've included a few references here.
Okay.
One is kind of getting started with Redshift Spectrum, which we're going to talk a little bit about in this presentation, which is part of the solution. Working with nested data through SQL. And then finally, the Glue data catalog and crawlers, which are kind of like the little known but very powerful services which help make this solution possible.
Yeah, sure. Perfect. And for our viewers, I will have these links posted in the description of this video as well. So thanks for the references, Elliot.
Awesome. All right. So before we get into like the technical details, I just wanted to kind of level set on like kind of the platform designs that we're solving for here. So at the top, we have what's called traditional ETL. And for those of you who are not yet data professionals or just a refresher on what this acronym means, in an industry that's got way too many acronyms, ETL stands for extract data, transform data, load data to a destination. And if you go back like, I'd say like 5 to 10 years ago, even further, this was like the default way of kind of like ingesting data into your data platform. And it was done for a couple of reasons. One, that database on the right was probably a relational database. So you had to like transform the data before you could shove it into that database. Additionally, this was, before we had like distributed systems and kind of like platforms like Amazon Redshift, where you might have a single like relational database server of fixed capacity sitting somewhere. So being able to like take some of this transformation processing out of the database helped you scale that whole system, much more. And then we have, what we do today, which is what we call ELT, which same letters, just switched around a little bit. You're extracting and loading that data to a landing zone. In many cases, this is going to be a data lake, probably built upon a service like Amazon S3, which can obviously hold all sorts of data. So you don't have that requirement to transform the data before it can be loaded into kind of an analytic environment. And then we have the transform, which we're building SQL pipelines. We're using tools like dbt because now we have like really scalable systems like distributed, MPP databases like Redshift and distributed query engines where we can start doing that work in the destination. So just wanted to kind of level set on these concepts before we got into the tech.
And Elliot, just to ask you over here, so both of these ETL and ELT are both relevant in today's world, right? So are there specific scenarios that you would suggest where you would say that ETL is better versus ELT?
Yeah, for sure. So I think like a very common place that you'll see an ETL concept being used is like, let's say, some sort of real-time like analytics store,
Sure.
right? Where
Hmm.
you might be doing some processing, maybe in a Lambda or maybe in some stream processing system, and landing it into some like NoSQL or kind of database that's really tuned for real-time analytics. So I see ETL a lot there. Where I don't see it much anymore is in like your classic like data warehousing use case. Those have almost completely
Completely shift.
shifted to kind of this ELT approach.
Okay, that's great to know.
And I'd also say that ETL has like a lot of kind of uses in like I'd say like more transactional systems where you might be doing data movement
I
outside
think
of
we used to
the.
have a lot of ETL processes earlier, especially with SSIS and BizTalk and
Oh yeah, those are
yeah,
the classic tools that you
tools, right? Yeah,
usually
the
see here,
yeah,
where we don't see them so much anymore,
more
right? Yeah.
absolutely.
So also as we talk about like these data sources, just to kind of highlight what we see today and why kind of this approach would be helpful is, a lot of our sources are still SQL databases or flat files, which I call kind of like the legacy sources. But very often we're getting data from application logs. We are getting them from like event contracts from like microservices. We're reaching out to APIs, which bring back paginated JSON, right? So we're dealing with semi-structured data a lot more. And we're going to talk about like why that might be challenging if you're trying to do ETL and how it's really going to work very well with this paradigm.
Sure.
So these are the challenges. You know, we're talking about data warehouses again, analytic systems. There's a lot of flexibilities even in Redshift with dealing with nested data. But for the most part, these systems are built around tabularized data, right? So you're forced to take like that semi-structured data and transform it, which is kind of ETL. Um, you've got like backfill and recast problems. Um, for non-engineers, if they want to write SQL, even if the SQL language does extend a bit to like allow you to get into like arrays and lists and stuff like that, it's really problematic and really difficult for them to deal with. And it's not going to work with a lot of the tools they use. And furthermore, you know, um, semi-structured data, like they add new fields and APIs, you want to reveal those fields. If you're pumping that data and storing it in a database, it's really hard to handle schema evolution because most of these systems expect that you're going to have a fixed schema, right? Um, so those are just a few of the challenges and that you'll run into with modern data engineering, so to speak.
Okay.
So a little overview of the technologies that we're going to talk about in demo today. So the first one, if you're not familiar with Redshift, I mentioned it a few times. Redshift is a managed data warehouse service from Amazon Web Services. You can run it in several ways. You can run provision nodes. You can set up serverless endpoints, which I'll actually demonstrate kind of passively today in my demo. And you can even kind of like use these clusters somewhat ephemerally. So like kind of spin them up, act on a data set, spin them back down. So there's a lot of like interesting ways that you can use Redshift, very flexible. It's petabyte scale. It's fast and economical. It probably has one of the best price to performance, kind of profiles of any of the cloud-based data warehouse. And what we're going to see today is that it integrates with many AWS services, which really, helps you with integrating data both to and from Redshift.
So in the real world, Elliot, I mean, being a data hero particularly, do you see that a lot of your customers are moving or shifting more towards Redshift? Do you see that as a trend in the market? Is this one of those services that the industry has embraced very well and it has accepted very well?
Yeah. So it's a good question. So Redshift has what I'd say a pretty large marketplace, very successful service. Um, they were the first, truly cloud-based data warehouse. And I think the service started like, well, I don't want to say like maybe 7 years ago, 8 years ago now. But now they have competition. There's a lot of very similar cloud data
Absolutely.
warehouses there. But I'd still say that Redshift is very competitive and well used. The engineering team has put a lot of fantastic work into this product over the past year, and things like serverless and their decoupling of storage and compute have really helped to make it stay competitive.
Sure. So for our viewers who've not probably explored this service, as Elliot said, maybe it might just make sense for you to just play around with it. Remember that when you play with any of these AWS services, you can potentially incur charges, so ensure that you release all resources after you are done. So absolutely. No, this is
Yeah.
really good, I mean. So we have Redshift, and then is the next one Glue on the list? Okay.
Yeah, so these are actually separate services, but they kind of work very well together. So I present
Sure.
them together. So Glue and Redshift Spectrum. So these tools together allow you to kind of virtualize your landing zone, as I was talking about. We're gonna see an example of that very soon. Basically, we're gonna apply what is referred to as a late bind technique to making your data available. And what does late bind mean? That means that you may be providing your end users like the view that they want, but you haven't done the pre-processing. The pre-processing, or the processing rather, is done in real time when they run queries. So I think if you're like a database person, this, at least conceptually, would be very close to a view, right? If you think of a view, you haven't actually moved tables together or joined them or done any of the work. It's just like kind of a logical construct which makes the data look the way that you want it. And obviously, just like a view, there's pros and cons to a late bind approach versus actually transforming data or moving data. But we'll talk a little bit about more about that. Um, the beauty of this is I mentioned it's going to handle schema evolution. It's going to avoid moving data around. You can leave your data in S3, collect it rather raw, and it supports this ELT pattern that I've been talking a lot about.
So is it both ETL and ELT or just ELT?
This would be supporting ELT.
ELT. Okay.
Yeah, because you're actually exposing the data directly into Redshift in this case. So at
Hmm.
that point, you would transform the data, right? So this is the E and the L in kind of ELT.
Okay.
So to give you guys an idea of the solution architecture, like how all these services work together, I'll start by talking about the Glue Metastore. So this basically provides like this catalog service, which basically describes what the data looks like outside of Redshift. So as you can see on the left-hand side, this crawler, if you look at the little creepy crawler bug, is waking up every few minutes and kind of like, or however you schedule it, and looking at all the data sources that you defined, right? It could be an S3. I'll tell you a cheat code that it could even be a relational database inside of AWS or several other sources where you can actually let this thing keep cataloging the data and adding it to a data catalog. So then what Redshift's actually able to do is reference this catalog and basically get a description of what the data looks like, a semantic view of what that data looks like external to Redshift. So what does that data look like on S3? What does it look on Postgres? How is it kind of projected into something like a table? So at this point, Redshift can query that data just like any other data that it has actually in Redshift storage, just a table that is resident in Redshift. And this is done through the Redshift Spectrum engine, which is basically a component of the Redshift platform, which is able to reach out and run these queries and return the results to Redshift for further processing.
Okay. So this is the overall architecture of the problem that we discussed earlier. Sure.
Yep.
And then you're going to demo this to us or parts of this to us today, Elliot?
Yeah, absolutely. So
Okay.
we're gonna do a demo. So the first service we're going to talk about, we're going to run this kind of cooking show style,
Okay.
because the crawlers, which we're going to talk about, take a little bit of time. But here I am at the AWS Glue console. There's a lot going on here. There's actually some really cool like data integration tooling, which is worth exploring. But we're going to focus mostly on the data catalog. So the data catalog, one of the highest level constructs that you have is this concept of a database. And much like a database in a relational database server or instance, It's just basically a container of all things that go together, right? Related to, in this case, like a single analytic application. So what goes inside a database? You guessed it, tables. So unlike tables in a normal database, these are virtual. They are a projection on top of data that we can run SQL on and kind of expose in other services. So as you notice here, I have two tables already defined. I have an activity log. It has a location in S3. It has a classification of S3. And this data can be immediately queried in Redshift, as we'll demonstrate in a few minutes. So I can go in here and I can add a table manually and define all that metadata, or I can be smart and use a Glue crawler.
So essentially, the classification over there is for CSV. So this is a CSV file in S3 that represented over here as a table.
It sure is. So I can actually, even go a little off script and click into it. And you can see that it's actually, kind of defined the schema for the CSV. This was all done automatically for the Glue Metastore by the crawlers. I didn't enter any of this. And yeah, if I had partitions on this data, which would be like logical foldering that can be used for performance optimization, which we can talk a little more about, that would appear here, and it's all auto-recognized by the crawler.
Okay.
So what we'll do is we'll go in and we'll create a crawler. So there's some more files out here, and I'd like to expose them so I can run some queries against them.
Hmm.
So I'm going to go in here and I'm going to create a new crawler, and this is going to be for an authors file.
And this is not a free service, right?
No, it is not a free service. It's very low cost though, very low cost. There may be some free tier capabilities for this, but I'd probably explore that before using the service if you're afraid of incurring cost.
Okay.
But it is, on the order of like dollars, right? Like if you wanted to play around with it for, some period of time. So I can go in here, I can define a data source. So I'm going to add a data source. So in this case, I'm going to browse to S3. I'm going to find the bucket that holds the data that I want. And in this case, it's authors, and that's just a folder. Don't really know what's inside it yet, but the Glue crawler is going to tell me. And I'm going to add this as an S3 source. So if I click next, it's going to ask me to, choose an IAM role. And we're going to look at the roles really, really quick. I am going to use an existing role. As I said, we'll dive into that definition in a minute, which will basically give the group crawler the ability to write to the Glue Metastore, which is the tables and databases we saw before, as well as access those objects on S3. And you can create a new IAM role here as well, which will handle most of it for you.
Yeah.
Although you
I've
might,
created videos earlier on creation of IAM roles, etc. So I think our viewers should be okay. But as long as they know this is a inbuilt role that they have, Elliot, or is this a role that you created?
it's a role that gets created with a custom policy and then uses like a standard role. I'll share it in a second. We'll take a
Okay.
quick look. All right, and then I just have to choose my target database.
Database. Okay.
And I'm going to leave it as on demand. I could schedule this or I could add a custom cron, but I'm going to leave it on demand and just hit next. And I'm going to create this crawler. And as soon as that crawler is created, I'm going to go here and I'm actually going to run it. So this is where the cooking show comes in. So this is cooking in the oven, and we're going to go look at some other stuff and come back. So the first thing we'll look at is the IAM roles. So I actually have up here, I'll show the other one first. Here's a Glue service role for authors. And you'll see that it has an inline custom managed policy here. And all it's doing is saying, hey, I've got access to this royalties folder in S3.
Okay.
And then the Glue service role is just giving Glue the ability to do what it needs to do in terms of working with S3, kind of having some EC2 writes, which I believe is how it executes the crawler, and so on and so forth. While I'm in here, I'm also going to show you one more role, which you need to set up if you want to access this data through Redshift. So this is just granting access to S3, which would be used for like your copy statements and whatever. The important one is this custom manage policy here, which is essentially saying, hey, I can work with Glue tables, right? I can read the metastore. So this is needed in order for Redshift to look at the metastore and get that metadata about tables and stuff on S3 and run queries.
Sure.
So what I'll do now is I'm just going to hop over to Redshift and do a quick demonstration. So as you can see here, oh, let me show this first. So in order to register an external schema, you just have to do this create external schema statement, which is in the documentation, and I've already run, so I won't run it again. But as you can see here, we're creating an external schema. We're able to name it, so it doesn't have to be video clickstream, but I named it video clickstream. From the data catalog, which is the AWS service of the data catalog, it's referencing the database, and it's referencing that IAM role, which we just reviewed, which gives it access to the Glue metastore. So by executing this, I now have an external schema, which looks just like my public schema in tables. And those external tables are now available as tables for me to access. So if I was to go in here and run a quick query on my clickstream log, oh, my connection might have reset. Hold on one second. There
Oh,
we go.
there it is. Okay.
Yeah. So as you can see, it was 1.3 seconds to reach outside of Redshift, access these kind of largest CSV files, and return the data back in tabular format.
Okay.
Well, that's very cool. But here we have an example of running a query which actually joins internal data with that external projection. And as you can see, that was pretty quick as well. We were basically trying to run a query to see if people who viewed these were on a trial membership or not. So as you can see, pretty performant. We were able to blend external data with, kind of data that was managed by Redshift. So think about, kind of your large clickstream files with your reference data. Keep the clickstream files out on S3, keep your reference files internal.
Okay. And then we still have that cooking, or is that cooked?
It is
That
cooked.
is
As you can
cooked.
see, the crawler is done.
Done.
If we go back
And
to tables and refresh,
you will see it over here. And just like how we basically queried activity log, we can actually even query this authors table.
that's correct. And you can see that it's JSON and classification. The only
Okay.
real difference, it's auto mine the schema. And if I go back, I can run a quick query. And there we go.
Awesome. Awesome. This is great.
And fun fact is this catalog is accessible everywhere, so you can run queries from within Athena on the same catalog.
Awesome. Perfect. Thank you so much. I think this was an awesome demo today. So this
Awesome.
is great. Yeah, I mean, I hope that our viewers really like this. Do try it out, team, at home. If you have any questions, comments, do post them, right? But Elliot, thanks for coming and thanks for showcasing this to us. And I'll request our viewers if they have any questions, concerns, or if they have any other topics that they would like us to discuss, to have them posted in the description of the chat window. And maybe certainly one of the days we can pick up one of those topics.
Awesome. Well, thank you very much.
Sure. Thank you, Elliot, and I will see you later. Thank you, everyone. Take care. Bye bye.